Hello everyone, welcome to this Linux Fundamentals. This is specifically for robotics applications. So Linux is the industry standard for robotics platforms and ROS, Robot Operating System. So this will equip you with essential Linux knowledge needed to work with robots. So here we will be covering two main areas, understanding the Linux operating system and mastering shell commands. So here, what is an operating system first? So an operating system is the first operating system is the bridge between you and the hardware, right? That is the user and the hardware. So here we have three core functions. So communicate and receive instructions from users, and then read and write data to disk drives, and then execute software applications. So Linux is inspired by Unix, that is a proven stable OS from 1970s. In GNU or Linux systems, Linux is the kernel, okay, while GNU which will provide all other components. So think of the kernel as the engine of the car. So it manages all resources. Applications are like dashboard controls, they work through the kernel. So here next. So why Ubuntu is Linux for robotics? Why Ubuntu Linux for robotics? So Ubuntu is the most popular Linux distribution for robotics. So it runs on Intel x86, AMD 64, ARM v7, ARM v8 processors. Okay. So it is perfect for desktop workstations and embedded robot systems. And there are key advantages for robotics is that it is a responsiveness, that is real-time performance is critical for robot control, and then lightweight, runs efficiently on resource constrained robots, and then for security, so important for networked robotic systems, community support, there's large robotics developer community, and then it has a long-term support, stability over 5+ years for production robots. So think of Ubuntu as the operating system built for makers and robotics. Okay. So here we see the Ubuntu desktop environment where Ubuntu has both a graphical user interface, that is GUI for beginners, and a command line interface, that is CLI for advanced users we have. Okay. Then key GUI components is Unity Launcher Panel, that is quick access to applications, Software Center, which is install or manage applications, and then System Monitor, so it monitors system resources, and we have File Manager, browse files and folders, and gedit, that is a simple text editor, the terminal, which is a gateway to command line power. So why this matters for the robotics is that GUI is user friendly for visualization and configuration, where the CLI, that is a command line interface, is where the real power lies. So this is what ROS developers use 90% of the time. Okay, the CLI. So we'll see in later how we open the terminal in the Ubuntu dash. Okay, how we will be searching for the terminal window. So next, moving on to, we have the Linux file system structure. So here Linux organizes files and folders hierarchically, similar to Windows, but with different directory names. So here we have /bin. So this purpose is that is essential system binaries, so which is the basic commands for all users, and /sbin. So this is the system admin binaries. It is where root or admin only will be using this. and then slash etc, which is system configuration files. And so equivalent of this Windows system is also present. So for example, slash bin is the Windows system 32 we have, which is equivalent to Windows system 32, and slash sbin, which is equivalent to system 32, that is the admin tools, and slash etc is system, it is equivalent to the control panel settings. Okay, it's a control panel settings. Slash etc is similar to, that is, it is equivalent to control panel settings in the Windows. And home username, that is users personal files and home directory, which is equivalent to the c colon users username. And slash library, which is with purpose is that it is a shared libraries, and it is equivalent to .dll files. And slash root, which is a home directory for root user, and that is the administrator. So here, unlike Windows with C, Linux uses or as the root separator. Okay, so everything in Linux is a file, which is including devices and configuration. And then next, moving on to this critical directories, where we have slash user, which is user installed programs and libraries, and var log, which is log files from applications and system, and dash slash opt is the optional third party software, so where ROS installs here in this. Okay, so and slash deb, which is device files, and we have a slash boot, which is files needed to boot the system, and then slash media we have, which is automatically mounted USB drives, CDs, and slash mnt, which is the manual mount points for partitions. So here, similar to whatever needed for the robotics, is that slash or opt slash ROS is where ROS gets installed here. Okay, and then we have the slash DEV slash TTY, that is USB, which is often where serial sensors connect. And understanding these parts is essential for robot configuration. And then next, moving on to this. So the Linux file system, which follows a standard hierarchy. So it is starting from the root and branches down into specialized directories. So everything is organized by purpose, not by application. That is configuration, which is present in the slash etc, and programs which is in the user or USR or bin or opt, and then we have data, which is in the variable. So why this organization which is matters is that it makes the system administration predictable and scalable, makes debugging easier, which knows exactly where to find the logs, and it is critical for robotics, knowing where sensors configurations and logs lie. Okay, so if a robot is, if it is not responding, then we'll be checking the slash var slash log for the error messages. So if we can't find an installed program, then we'll be checking for the slash opt or slash usr or slash ban. Okay, so now as of now we have seen what are the directories present in the Linux, which is equivalent to that of the Windows. Next, we'll get introduced to the shell commands. So in Linux OS, we'll be having where the menu option, so where we'll be having the terminal panel. So this is the command line interface in Ubuntu. So hold on. So this is the terminal window. Okay, so this is the command line interface in Ubuntu. So while the GUI tools are convenient, advanced robotics work requires this CLI. So why this CLI is essential for robotics is that it is faster than clicking through menus, and also it is powerful debugging capabilities it has, and it is necessary for ROS development and industry standard in robotics lab and companies. Okay, so we know how to open this Ubuntu terminal. So you will be having Ubuntu dashes will be there on the left hand side. So and it will be having the terminal we have as I've shown you at the terminal panel presence. Okay, so if you are working with ROS, you will spend most time in the terminal. Okay, so learning shell commands is necessary for the robotics. Okay, so first we'll start off with learning the shell commands. So first, if you want to what are the commands you can see over here. So what commands we have is that is for man we say the command we call these as shell commands. Okay, so first command is the man command, which is the manual pages for any shell command. For example, so suppose if I type in man, so for example it is showing you which is the man command URL. So manual pages for any shell command will be having. So actually this is your this is like the best friend in the terminal. Okay, so you will be having the usage as man space what is the command you will be having. Okay, for example if I give as man space the command you have to give like ls. Okay, it shows the manual for the list command. Okay, so suppose if I give as man ls. Okay, so it is showing you the manual for the list command. So why this is necessary or why this matters is that here you cannot remember the command syntax. So at that time you will be using the man and want to learn command options what are the present there. So we'll be using that time man. And if it is disconnected from the internet, so this man pages are local and always available. Okay, so for this purpose we'll be using this man command. So if you just give man ls, okay, I have shown you now how this man ls works, and if you just press q it will quit and it will come out of it. Okay, and next we'll be learning the commands for managing files and folders. So here these are the most frequently used commands in the robotics, that is which shows files and folders in the current directory. For that we will be using just as ls, so that is list. So it will be listing the commands whatever in the it shows the files and folders in the current directory. So in the current directory, in the sense here it is the here I have installed the virtual machine. So in virtual machine whatever is present in the home page. Okay, so whatever is present over there, that is being listed. So here it displays all the files and folders in the current location. In this location whatever is present over there, it has been present. Okay, then the other command is that it is the cd stands for the change directory. So it navigates between the folders. Okay, so for example how we have to give this command is that it is a cd space you have to give that particular path. For example here in list we have seen many folders or files were present. Okay, so I'm giving just a cd space. For example I do have here as a desktop. Okay, which means I'm changing the directory into this desktop. So if we just put in this, so we have moved now into, if you see here we have now moved into the desktop where we have here virtual machine, inside which inside the desktop we are now inside the desktop. Okay, so we have changed the directory into the desktop. Okay, and then if now you can just give ls and check whatever is present over there. So in desktop nothing is there, so no files and folders are there, so it is just giving you the empty, it is returning back again. Okay, and next you have other command called as a pwd. That is the print working directory. It is not password, it is a print working directory, that is pwd. So it shows your current location or the absolute path. So it is always helpful when you are lost in the file system. Okay, for that this is being used. So print working directory. And then we have other command, that is the fourth command is called as the mkdir, which is the making the directory, make directory. This is called as the make directory. So here you are going to create a new directory, or we say in that case it's a creating a new folder. Okay, so make directory space any folder name. For example, I am just saying it as a ROS. So make directory, I'm making a directory new, I'm creating a new folder named as ROS. Okay, so in desktop I have made this. So if I just put ls and check, you will be having that ROS folder. Clear? Now if you want to move in that ROS folder, if you want to go and type some, suppose any programs, you have to change the directory. You will be giving it as a cd space ROS. Okay, so this is the use of the make directory. So if when we will be using this make directory, is that use the make mkdir to organize your ROS workspace. So and then use the cd and pwd to navigate between the code, config and log directories. Okay, so for this purpose you will be using that. And next will be next command, we'll move on to the next command, that is rm. Rm is for the deleting the file. Okay, delete or removing the file, you will be having the rm, that is remove space file name. Okay, so here in this case when you give this rm command, so it is, that is rm space any file name you have to give. So in this case the files will be permanently deleted. It will not be in the recycle bin and all. It will be permanently deleted. It is similar to that of your shift delete in Windows. Okay, and then we have advanced version of this is we have rm space -r and then space that folder. So it will delete the folder and all its contents. Okay, for that this command is used, rm space -r space folder name. So you will be having the, for example, rys. So suppose in this folder rys, if I have many files being created, if I delete this ROS rm, if I use this command to delete the rys folder, means whatever files present inside that, everything will be deleted. Okay, and if it is in the case of whether it is, if it is in the root, so here root is the administrator, it is equal to just relate with the Windows OS and this, and then you just learn. Okay, so here root is the similar to that of the administrator. So if something doesn't delete or something doesn't work, you have to use the keyword as sudo rm. If you want to remove a file, if it doesn't remove, then it has been present in the admin file. Okay, administrator. So you have to delete that with the root privileges. So you will be using that keyword called as a sudo. Before any command, you use the sudo. Okay, and next we have other command called as the rmdir, which will be removing the empty directories only. So now if you just check, it is having rys is the empty directory. It is a directory or folder, right? So rmdir with, you can, if you give away the file name or the folder name, it will first it must delete the files inside that first, and then it will be deleting that. Okay, now if you just check ls, nothing is there, which means this has been deleted. Okay, you are removing the directory, rm directory is remove directory. And then you have other command called as the move. Okay, so move file to new location, or if you want to rename it, you will be using it as a mv. Okay, so move a file to the new location or to renaming it, mv space. Okay, you will be giving the source and then space destination. So for example, just I am telling it as a mv space, the source is test.txt. Okay, and then space you have test2 dot txt. So which means mv space, this is your source name, test.txt is source name, and test2.txt is the destination. Okay. So which will be renaming in the same folder. Okay. So here I don't have that. So I haven't created the test.txt, so I couldn't move it. So how just I'm showing the usage of this. Okay. And then you can copy a file. So copy the file from one location to another. We will be using that as a cp. Cp command is for the copying the file. Okay, copying file from one location to another. Cp again space. Again you will be giving it as the source and then destination. Okay. So you have to have always backup robot configuration files using this CP for copy, and then use MV to organize the sensor calibration data. That is in case of the robotics, and use RM-R. So as we have seen earlier, what is that RM space hyphen R? You have to use it carefully only on the temporary directories. Okay. And then robotics debugging requires understanding the system state. So these commands which helps diagnose hardware and system issues. And we have the other command called as the demessage. Okay, so DMESG. So which will be displaying the kernel messages. So it shows kernel logs and system messages. So usage is just you have to give DMESG. So which is critical for debugging USB devices not detected driver issues for this. Okay. So robotics use will be check if the motors sensors connected properly. Okay. And then we have LSPCI. So LS, it is for the list, and LSPCI together, it will be listing the PCI devices. It shows all PCI hardware. So this has to, so here, why this operation not permitted in the sense, it is inside the desktop, right? Now if you want to come out of it, you have to give it as cd space dot dot, which will be coming one folder backward. So again I have come into the root. Okay, so now just I'm giving it as, I need to give that as DMESG. So if you don't want to type again the same command, so what you will be doing is that you press the top and the bottom arrows. So whatever the commands you have used earlier, that will be listing you. Okay, and then you have as I said, you have to just check for LSPCI. So this will be listing the PCI devices, whatever is present. So it shows all PCI hardware. Okay, Intel or AMD devices, whatever is there. It is used for detecting network cards, graphic cards, etc. Okay, so for that this will be using. And you have LSUSB. So it will be showing all connected USB devices actually. So here it finds the serial connections to Arduino leader cameras. So in case of this robotics, so if your sensor is not working, we can check LSUSB first. Okay. So if the motor is not responding, then we'll be checking for LSUSB for connection, and if the stains errors on startup, then we'll be checking for D message for kernel errors. And if you can't find this one, so you will be running the LSUSB to verify the device. And then just we'll be next checking for the process management commands. So in robotics, we often run multiple programs simultaneously. So we need to monitor and control the running processes, right? So for that, we have the whatever the running processes, we have to list the running processes. For that, we'll be using it as a PS. Okay, it shows the processes currently running. Okay, So how we'll be using is this ps the current terminal. For example, all system process if you want to run, so you will be just giving it as ps hyphen a. Okay. Yes, just ps. Okay. So here will be output will be this PID and the terminal type and the program name. So when it is useful, it find if the ROS node is still running. Okay. In that case, you will be using this. And then we have uh, other command for the interactive process viewer. We have the other command called as the htop. HTOP. So real-time process monitor, it is like a task manager in the Windows. Okay, the usage is like just the htop. So it shows the CPU memory usage for each process. It install first, that is first what actually we need to do is set is already showing. Okay, sudo apt get sudo space apt hyphen get, and then you have to give install htop. Okay, here this is critical for robotics. It monitor if the vision processing is hogging CPU. Okay, so this is for the real-time process monitor. Okay, and we have the other command called as the kill. So if you want to terminate a process, the command is the kill. So if stop a running program by its PID means you have to say it as a kill space its PID. Okay, for example, if you say kill space the PID is 2573 something. Okay, it will stop the process with this ID. This is what it does. Okay, there's just no such process is there, otherwise it will do that. Okay, for that only first we have to find which PID using this ps or htop, then we can stop the running program. Okay, so ROS node won't stop at all, so we'll be using that kill with that PID. And then system running, it is slow means we will be using HTOP to find the resource hungry process. Okay, check if sensor driver is running, then we'll be using ps to verify that. And then next we just check for administrative and installation commands. So ROS and robotic software require administrative powers, so package management is essential for the robot setup. So for that we'll be, as I said earlier, when we want to use that as an administrator, we'll be setting that as a sudo, right? So run commands with the root privileges. So we'll be using that generally as a sudo. So as I said, apt hyphen get install ROS hyphen core. Okay. So here, which means that here you are running this as an administrator. You are trying to run this as administrator. So that is why you are using the keyword as the sudo. Okay. So where you will be using this sudo sparingly only when it is necessary. And if you want to switch to root user completely means you will be using that as a sudo space hyphen I. Sorry, this actually space hyphen I. So which means always you will be switching to root user completely. Okay. So apt-get, we are saying sudo apt-get, right? So this is for the install or manage the packages. So Ubuntu is a package manager and it is critical for ROS. So sudo apt-get space action and package. So usually what you will be doing is that sudo apt, for example, apt-get, you say update. So this will be refreshing the package list. And if you want to install some software, so sudo apt-get install. So instead of that update, you will be having it as install space what is a package. And if you want to remove install, instead of that install, you will be giving it as a remove, for example. So here this update you can give, so it will update you. And then if you want to install some packages, you will be giving sudo apt. Yes, I'll show you. So this is actually I'm updating this. So if you want to install packages, for example, sudo apt get install, and then you have to give the package name, right? So for example, here you have, instead of this update, you have install and then space package name. For example, I require python 3 hyphen pip. So this will be installing the Python package manager, right? And if you want to remove this, instead of this install, you will be giving that as remove, remove, and then space that package name. Okay. So here and then dpkg, you have other command called as the dpkg, which will be installing the local packages. So for that, first you have to install .deb files directly. Okay. So for the offline installation, so usage is that dpkg space hyphen I space file name .deb. Okay. So this is useful when you have the pre-downloaded packages for robots in the field. Okay. So this sudo apt update I have shown you, and then install of any packages you can do it. Python 3 hyphen pip, whatever packages is required, that time you can give this command. Okay. So next is the final set of critical system commands for the robotics is that the reboot. So for restarting the system, for restart the computer immediately, you will be just giving it as the sudo space reboot. So for that, this will be restarting the computer immediately after installing drivers, updating kernel for the robots. Okay. So if you want to shut down the system, you just give sudo power off. Sudo space sudo space power off. So this will power off the computer. Okay. So it is a graceful shutdown, better than force power off. If you just give this will shut down the system. And then we have text editor in the terminal. Okay. So if you want to edit the configuration files directly in the terminal, we will be using that as nano. Okay. So that is a nano space file name. So first you have to create a file. Okay, make the directory, that is create a file, and then create a file. You will just say nano space file name. For example, first creating a directory, just I'll make the directory and show you. So mkdir space ros I have made. Okay. So which means if I put ls, I will be having here as ros or os is already present, which I have made the directory. Now if I want to go inside that folder, so I'll be changing that directory to ROS, which is now I'm inside the ROS. So I'm just going to create a file. So for creating a file, you will be using the command as touch space any file. For example, just I'm creating txt.py. I'm just creating a file. Okay, now if I give ls, I will be having the txt.py. This is a file name I have been created. Okay. Now if you want to edit that configuration files directly, that means I'll be giving that nano space. I have to give that file name. Okay. So I'll be giving that as nano txt. So which means I can edit over here directly. Okay. So this is useful for the ROS configuration file scripts and settings. Okay. So if you want to, after typing the after you're done coding, you have to say Control and O for the saving. Now you can give here the file name that is the file name to save it. Okay. And then you have to give exit. For exit, Control X. It will come out of it. Okay. So if you want to edit the ROS launch files, for that time you will be using this nano command. Okay, nano space your file name, which will be can able to edit, and if you want to save it, you will be giving it that as control O to save the file. And then if you want to come out of that nano part and come to the terminal here, you will be using control X to come out of it. Okay, so here, so you have just seen, right, what we have done so far. So let's put it all together with a realistic robotic scenario. This first you need to navigate to the, we have seen, navigate to the workspace, create robot workspace, and check if the connected hardware is there. Okay, you can just take note down this and you can check it. First step, you have to navigate to the workspace. Okay, and then create the robot workspace and check connected hardware. So first step, you are just going to connect it to the navigate to the workspace. For that, you will be using cd/opt. Okay, just telling only, you just try it out and check. So pwd is for verifying the location. And then next step is to create the robot workspace. So for creating, you will be using mkdir. This is for the creating the directory, workspace, or folder, we say mkdir. But if you want to create a file name, for that only we will be using it as a touch, touch. Okay, so you, for creating the robot workspace mkdir, some robot workspace name you will be giving, and if you want to go into that, you will be changing the directory cd space whatever you have created the directory name, that you will be giving, right? Then third step, check the connected hardware. So for checking, they can see if their sensors are detected. For that, you will be using ls usb. And then check for errors. So you will be using dmesg. Okay, dmessage. And fourth step is create the configuration directories. For that, mkdir space config, mkdir space logs, mkdir space calibration. You will be using that. And view the running process to see what else is running. Okay, so for that, ps space hyphen a you will be giving to find the ROS processes. Okay, then install the required packages. For that, first you have to update it, that is sudo apt get update, then sudo apt hyphen get install whatever the packages you require. Here ROS4 if you require, you can install that. Okay, and if you want to edit the configuration file, you know how to create a file, and then by using the touch .txt, and then by using the nano you can create and then edit the configuration file. Okay, now monitor the system during the operation. For that, you will be using the command as htop. Okay, so always check ls usb before blaming the code for the sensor issues, and then use this nano to quickly adjust parameters during the testing, and monitor with the htop to catch the resource bottlenecks early. Okay, so actually here you have to learn from the mistakes to save the time in robotics. Okay, so what you are not supposed to do is that rm space hyphen r. I actually told you it is deletes the entire system, right? So don't do this, because double check the path before using rm hyphen r. And also, while you are forgetting the sudo on administrative tasks, that is, if you just give apt-get install ROS4, it will fail without the sudo. Okay, you have to give the sudo command before. And when you are not using the man command, when it is stuck, okay, it will take Google for the 20 minutes. But if you type man space command for the install, you can use that for the instant help. And not to do is that assume files are in the current directory. For that, you have to use the pwd plus print working directory and the ls to verify the location. And then you have the killing the random process. So for that, you use ps instead of kill process without knowing what they do. So instead of that, you can use ps to identify the process first. Next, you for not backing up configuration, modify critical files without the backup. So don't do that. So instead of that, you can use the cp command for copying. Okay. So actually what you have learned so far, the basic shell commands is that, so Linux OS fundamentals you know, and why Ubuntu is ideal for the robotics. And then you know what are the file system structure and how to navigate to it. And you have seen several shell commands, the basic commands, which is covering the file or folder management, system debugging, process control, software installation, right? Actually, so this and also you have seen the system configuration. So why this is mainly important for robotics is that ROS, that is a robot operating system, runs on Linux. So professional robotists use the CLI daily. This is command line interface every day. System debugging requires a Linux knowledge. Hardware integration relies on device paths and permissions. So what you will be doing this, just don't visualize this alone. You just practice these commands on your own Ubuntu machine. So install ROS once comfortable with the Linux basics, and explore the documentation using the man packages. So set up your robot workspace using commands which has been learned in this video, and then you can actually join the robotics communities, that is